Section 10.4. Comparing two population proportion with independent samples. There are many interesting applications in which a hypothesis test can be used to compare two population proportion, such as the following. An insurance company would like to know if the proportion of young male drivers who have car accidents differ from the proportion of young female drivers who have car accidents. A bank would like to compare the proportion of young customers to the proportion of older customers who pay their bills online. To demonstrate this technique, let us use the following example. The recent economic downturn has had a negative impact on the nation's home ownership rate, which is found by dividing the number of owner-occupied housing units by the total number of housing units. Suppose the government would like to compare this rate in the Southeast United States to the rate in the Southeastern United States. A random sample of 150 Southeastern homes was drawn, and it was found that 105 were owner-occupied. A random sample 125 Northeastern homes was drawn, and it was found that 80 were owner-occupied. Let the population are as follows. Population 1, Southeast. Population 2, Northeast. Please check figure 10.13. We will use the following notation. P1 is the true proportion of owner-occupied home in Southeast. P2, the true proportion of owner-occupied home in the Northeast. P1 bar, the sample proportion of owner-occupied home in Southeast. P2 bar, the sample proportion of owner-occupied homes in the Northeast. N1, the sample size from the Southeast population. N2, the sample size from the Northeast population. Graph 1 and Graph 2 in figure 10.13 show the sample distribution for the proportion for each of the two population. Graph 3 shows the sampling distribution for the difference in proportion. This new distribution is the result of subtracting one sampling distribution from the proportion from a second sampling distribution for the proportion. A key question in this figure, the standard deviation of this new distribution, which is known as the standard error for the difference in population proportion, as is shown in equation 10.19. Formula 10.19 for the standard error for the difference in population proportion. A sigma of P1 minus P2 equal to square root of P1 times 1 minus P1 divided by N2 plus P2 times 1 minus P2 divided by N1. However, it is the value of P1 and P2 that we are trying to estimate because they are unknown. The solution, we replace P1 and P2 with P1 bar and P2 bar, which are the sample proportion taken from population 1 and population 2. Doing so gives us the appropriate standard error for the difference in population proportion. Formula 10.20 for the approximate standard error for the difference in population proportion. Sigma cap of P1 and P2 is equal to square root of P1 bar times 1 minus P1 bar divided by N1 plus P2 bar times 1 minus P2 bar divided by N2. We will put this equation to work. First, we need to calculate the sample proportion as follows. P1 bar is equal to X1 divided by N1 equal to 105 divided by 150 is equal to 0.70. P2 bar is equal to X2 divided by N2 is equal to 80 divided by 125 equal to 0.64, where X1 and X2 are the number of owner-occupied homes from southern and northern samples, respectively. Plugging these values into equation 10.20, we have the approximate standard error for the difference in proportion. Sigma cap of P1 minus P2 is equal to square root of 0.7 times 1 minus 0.7 divided by 150 plus 0.64 times 1 minus 0.64 divided by 125 is equal to square root of 0.003243 is equal to 0.056947. Notice that the shape of all three sampling distributions in figure 10.13 appear to resemble the normal distribution. Recall from chapter 7, proportion data follow the binomial distribution, which can be approximated by the normal distribution if we have relatively large sample size. In this section, we will assume our sample size are large enough to meet this requirement. We are now ready to start comparing these two populations. We will begin with a look at constructing interval and then wrap up this chapter with one last hypothesis test. Using a confidence interval to compare the difference between two proportions. Our point estimate for the difference between population proportion is simply the difference between the sample proportion, P1 bar minus P2 bar. In our example, the estimate for the difference in home ownership rate between the southeast and northeast is as follows. P1 bar minus P2 bar is equal to 0.70 minus 0.64 equal to 0.06. We can construct the confidence interval around this point using equation 10.21 upper limit and 10.22 lower limit. Formula 10.21 and 10.22 for the confidence interval for the difference between two proportions. UCL of P1 minus P2 is equal to P1 bar minus P2 bar plus Z alpha divided by 2 sigma cap P1 minus P2. LCL of P1 minus P2 is equal to P1 bar minus P2 bar minus Z alpha divided by 2 sigma cap P1 minus P2, where UCL of P1 minus P2 is the upper limit for the confidence interval. LCL of P1 and P2 is the lower limit for the confidence interval. Sigma cap P1 minus P2 is the approximate standard error of the difference between two proportions. See equation 10.20. Let us construct a 95% confidence interval to estimate the true difference between the ownership rates between the southeast and northeast. We can use table 10.1 to find the appropriate critical z-score by identifying the row with an alpha value of 5% and two tails. Remember, all confidence intervals have two tails. Our critical z-score is set at z alpha divided 2 is equal to 1.96 for this interval. From the previous section, we know that sigma cap P1 minus 2 is equal to 0.056947. Putting equation 10.21 and 10.22 to work result in the following. UCL of P1 minus P2 is equal to P1 bar minus P2 bar plus Z alpha divided by 2 sigma cap P1 minus P2. So UCL of P1 minus P2 is equal to 0.06 plus 1.96 times 0.056947 is equal to 0.172. LCL of P1 minus P2 is P1 bar minus P2 bar minus Z alpha divided by 2 sigma cap P1 minus P2. LCL of P1 minus P2 is equal to 0.06 minus 1.96 times 0.056947 is equal to minus 0.052. Our 95 confidence interval is between minus 0.52 to 0.172. This means we are 95% confident that the difference in ownership rate between the Southeast and Northeast is between minus 5.2% to 17.2%. The minus 5.2% simply refers to the possibility that the ownership rate in the Northeast or population 2 is 5.2% larger than the rate in the Southeast or population 1. Because this confidence interval does include 0%, we have no evidence that the home ownership rate are different between two sections of the country. Conducting a hypothesis test to compare the difference between two proportions. When performing a hypothesis test, the difference between two proportions, the null hypothesis assumes that the population have equal proportion, P1 equal P2. Therefore, we have three possible hypothesis statements. Two-tailed. Null hypothesis, P1 minus P2 equal to 0. Alternative hypothesis, P1 minus P2 not equal to 0. One-tailed. Null hypothesis, P1 minus P2 less than or equal to 0. Alternative hypothesis, P1 minus 2 greater than 0. Another one-tailed is null hypothesis, P1 minus P2 is greater or equal to 0, and alternative hypothesis, P1 minus P2 is less than 0. Example case, suppose the government would like to perform a hypothesis test to decide whether there is enough evidence to conclude that there is a difference in home ownership rate between the Southeast and Northeast using an alpha equal to 5%. We will demonstrate this procedure using the following step. Step 1. Identify the null and alternative hypothesis. Because we are testing for a difference in rates rather than testing if one section is greater than the other, we have the following two-tailed hypothesis test statements. Null hypothesis, P1 minus P2 equal to 0, or no difference in ownership rate between regions. Alternative hypothesis, P1 minus P2 not equal to 0, ownership rate are different between regions, where P1 is the true proportion of owner-occupied home in Southeast. P2 is the true proportion of owner-occupied home in Northeast. Step 2. Set a value for the significance level alpha. For this example, we had a set alpha equal to 5%. Step 3. Calculate the appropriate test statistic. When we assume that P1 equal to P2 with the null hypothesis, we can estimate the overall proportion between the two populations using equation 10.23. This is known as the pooled estimate of the overall proportion, or PCAP. This is analogous to the pool variance for a difference and means that we used earlier in the chapter when we assume the population variances are equal. Formula 10.23 for the pool estimate for the overall proportion P cap is equal to x1 plus x2 divided by n1 plus n2. This is simply a weighted average of the two samples proportion taken from the population. Using our home ownership data, we have the following. P cap is equal to 105 plus 80 divided by 150 plus 125 equal to 185 divided by 275 equal to 0.673. So our estimate of the home ownership rate of both sections combined is 67.3%. Now we can calculate the test statistic for a difference between population. ZP or Z of proportion using equation 1024. Formula 10.24 for the Z statistic for a hypothesis test for the difference between two populations. ZB is equal to P1 bar minus P2 bar minus P1 minus P2 of null hypothesis divided by square root of P cap time 1 minus P cap time 1 over N1 plus 1 over N2, where P1 minus P2 of null hypothesis is the hypothesized difference in population proportion. Our test statistic for the home ownership example is as follows. ZP is equal to 0.70 minus 0.64 minus 0 divided by square root of 6.673 times 1 minus 0.673 times 1 over 150 plus 1 over 125 is equal to 0.06 divided by 0.56815 equal to 1.06. Step 4. Determine the appropriate critical value. Because the test statistic is equation 1024 follows the normal distribution, we can use table 10.1 to determine the critical value. Z alpha divided by 2 for a two-tailed test with alpha 5%. Our critical Z score is alpha divided by 2 is equal to 1.96. Step 5. Compare the Z statistic or ZP with critical Z score or Z alpha divided by 2. In our home ownership example, which is a two-tailed test, ZP is absolute value of ZP is 1.06 and absolute value of Z alpha divided by 2 is 1.96. Because 1.06 less than 1.96, we fail to reject the null hypothesis. Figure 10.14 illustrates this finding. Notice that ZP is in the do not reject region. Step 6. Calculate p-value. The two-tailed p-value for home ownership example is as follows. P-value 2 times P of ZP greater than 1.06 is equal to 2 times 1 minus 0.8554 or equal to 2 times 0.1446 or equal to 0.2892. The total area of the two shaded A region in figure 10.15 represent this p-value. Because our p-value is 0.2892 and is greater than alpha 5%, we fail to reject the null hypothesis. Step 7. State your conclusion. By failing to reject null hypothesis, we conclude that we do not have enough evidence to support the alternative hypothesis, P1 minus 2 not equal to 0. We cannot conclude that the home ownership rate are different when comparing the southeastern with the northeastern part of the country. Thank you.